Hi everybody, Mr. Lee here. In this video we're going to go over motion maps, and motion maps are just another way to model how things move. Now for this part of the course we are just dealing with objects with constant velocity, so if you remember from the previous video, they're not speeding up or slowing down. Okay. Another way to describe this is we are going to be modeling how things move using this thing called vectors. In the previous video I did go over what a vector represents, but just in case you missed that, let's copy these definitions down. Alright, so here we have two definitions. The first one is called vectors. Now, vector is something with both magnitude and direction. So magnitude for our course is just a number, and direction can be anything like up, down, left, right, north, south, east, west. Okay, and our example here is velocity. Velocity is a variable that is a vector. Okay, because yeah, it has both magnitude and direction. Now, another way that I like to memorize it is velocity starts with a v, and so does vectors. Okay. Now, over here we have scalars. Scalars is just a magnitude, and for our part of the unit, this is just speed. Okay. You'll recognize that a scalar is the same as a vector, but without the direction, and that's very important. In the case for the scalar, it has just the number, and I'll show you an example a little bit. But first, easy way to memorize which one is which. Speed starts with s, and so does scalar. So, for example, a vector can be like 2 meters per second up, right? Where the 2 is the magnitude and up is the direction. And a direct comparison would be speed, which is just 2 meters per second. Right? Now, another way to remember this is that in a car, if you look on your dashboard, you have what we call a speedometer, which tells you how fast you're going. Okay, the magnitude, but it doesn't tell you what direction you're going, and that's what the compass is for. All right, so with that out of the way, let's begin. So what I'm going to do is I'm going to show you two different scenarios. The first scenario, it says Mr. Lee is running to the right at a pace of 3 meters per second. Okay, and what I did is I highlighted both the direction and the magnitude to show you that we're dealing with vectors. Now pause the video right here, and because we're about to add to this scenario, copy it down. Okay, compared to scenario 2, Mr. Lee is running to the right at a pace of 5 meters per second. All right, so same direction, but I have a greater magnitude. Okay, now to actually draw these motion maps, I'm gonna draw one. Let's draw one right below it. Okay, so let's start off with scenario 1. So to begin, I'm gonna just draw a very basic motion map, meaning we're not going to add any numbers, but for this one we're just going to do something where we can just visually tell the difference between scenario 1 and scenario 2. So what I did is I drew a long arrow, so you could think of that like a number line, okay? And this number line, or this this path, represents the object's position, where we can say here, this can represent 0 meters, and over here, this can represent something like 100 meters. Okay, so this is like a number line where right in the middle can be like 50 meters. But for this video, we're just going to keep it as general as possible. So I'm going to get rid of that, so we don't have to worry about any numerical things. All right, so scenario 1, we have Mr. Lee. You're going to represent me with a dot, and you're going to show that I'm moving to the right with the pace of 3 meters per second. Now, once again, because we're not dealing with numbers necessarily, I'm just going to draw it very generically. So that is me. Oops, that's just me, and I'm running to the right. Okay, this is me, and I'm running to the right. I'm just gonna draw the rest like this. All right, there we go. There we go. Okay, so this is scenario 1. Now, here's a couple important things to know. I drew my position at every 1 second. Okay, now I didn't tell you this ahead of time, but let's say we are dealing with a problem. It's important to know that each dot represents a equal interval of time. So for example, right here could represent time is equal to 0 seconds. Right here, it could represent time at 1 second. Here, it could represent time at 2 seconds, and so on and so on. Okay. Now, it's important that you keep the intervals the same, because that's how we like to create our graphs and our tables. But it's just a more natural way to imagine things, right? Things at a constant interval. All right. Another thing that you'll notice is that my blue arrows, okay, which represents my velocity. So let's write that down. So these arrows represents velocity. Reps velocity. Okay. You'll notice that my blue arrows they should be relatively the same size. And that's because I'm moving with a constant velocity. Remember, this whole unit is about objects moving with a constant velocity. It doesn't speed up or slow down. Okay, so I have the same size arrows, right? And that's it. Okay, that's how we can show you how fast I'm going. Okay, based on the size of the arrows and where I'm at. If you're wondering, well, how do we know where you're at? Well, at 0 seconds, I'm here. At 1 second, I'm here. At 2 seconds, I'm here. At 3 seconds, I'm here. And at 4 seconds, I'm here. All right. Now, if we were to solve this mathematically, we know that moving at 3 meters per second. Okay. So once again, this is a little bit more advanced once we get used to drawing these things. But you know, you could probably pick it up. At 0 seconds, I'm at 0 meters. At 1 second, I'm at 3 meters because I'm moving every 3 meters for every 1 second. So here I'll be at 6 meters. Here I'll be 9, and here I'll be at 12. Okay. So that's a little bit more advanced. But once you get the used to drawing these, it just shows you how we can add to these models to give a better representation. All right, now what about scenario 2? Well, I'm going to draw you scenario 2 right below scenario 1. So here will be scenario 2, and I'm going to represent that with a different color. Okay, so we're both starting at the same location, but notice here, I'm drawing my velocity vector a little bit longer. Okay, and the reason for that is I'm moving faster. Okay, so if we were to compare my velocity vectors, my velocity vectors between scenario 1 and scenario 2, I can see that in scenario 2, I am clearly moving faster. Now, another thing that I want to point out is that my only starting position, okay, is the same. We both started at 0 meters. Think of it like a race, right? Everyone starts at the starting line. But you can see here at 1 second, scenario 1, I was here, but scenario 2, I'm further ahead, meaning that because I'm moving faster, right, just like in a real race, I'll be further ahead in the race. And so for here, this will be like 1 second, but you can see here, I'm further ahead, right? So I'm constantly getting further and further ahead, right? So that's all there is to it for these type of scenarios when you're drawing the velocity vector model. All right, the next scenario, what we're going to do is we're going to just change things up. Okay, we're going to add to the scenario. So once you are done copying this, copy down scenario 3 that you'll see in a little. All right, here's scenario 3. So Mr. Lee moves to the right at constant velocity, stops and remains in place for 2 seconds, and then moves to the left at a slower velocity. So one thing that you'll notice is that I didn't add the actual magnitude of my motion, just to show you that these models can be used to have a general representation of what is going on. All right, let's begin. So the first thing that I want to do is I want to create a position line, like so. And you'll notice that a highlight remains in place for 2 seconds because that's something new that we haven't seen. All right, so here's my position line. What I'm going to do is I'm going to say right here, this is the 0 meter mark, and we'll say that anything to the right is positive, and you'll see why in a little bit when we get to the graphing portion of this video. Okay, and I will say, you know what, I'm not going to start at the 0 meter mark, okay? In the previous examples, we always started at the 0 meters, but that won't always be the case. So I'm going to start here. I'm going to move to the right. Let's see. We got a little bit, arrows a little bit bigger, just to show you that we are moving, we're moving fast, okay? But more specifically to show you that we're going to be slowing down. All right, so here we have us at 0 meters, and then 1 second has passed, 2 seconds passed, 3 seconds passed, and then we stop. Okay. Now to represent that we have stopped for a total of 2 second intervals, I will draw 2 dots there with no arrows. That should show you that for 2 seconds I did not move. And then I move to the left, and I'm slower now. Okay, and to show that I'm moving slower, I'm going to draw my arrows smaller, like so. All right, so here we see that at time 0, I'm moving to the right. And after 1 second, 2 seconds, I am now here, wherever that is. And for 2 seconds there, I am not moving. I'm actually paused, and then I move to the left at a slower pace. And that's all there is to it. All right, now with that being scenario 3, that's probably the most complicated one that we will see for this video. What I want to do is I want to combine this back to the previous video with graphs. All right, so here we have scenario 1 and scenario 2, and what I'm going to do is I'm going to create a graph for both scenario 1 and scenario 2 on the same graph, because for our class, what we'll be doing is we'll be combining multiple models together to get a full representation of what's really happening. All right, so if you remember scenario 1, I was moving to the right with a velocity of 3 meters per second, okay, where this is my slope. And if you remember, slope is rise over run, or the change in the y-axis, which is delta x, over the change in the x-axis, which is delta t, and displacement over time is velocity. Okay, compared to scenario 2, where I believe I was moving faster, and we started off at the same spot. So here I have a greater slope, and for this one, what did I say? How fast was I running for scenario 2? 5 meters per second. There we go. So for this one, my slope is going to be 5 meters per second, and scenario 1, I believe I was at 3 meters per second. All right. So a couple of things I want to point out. One, scenario 2, I have a greater slope. Okay, and it is steeper. But more importantly, the slope is positive. Okay, it's moving upwards, and that's to show you that for this case here, positive means to the right. Compared down below, where it is also moving positive, slope is positive. Okay, because we know that because it's moving upwards, and that just means to the right. Also important here, I didn't do a good job of drawing it, but we started at same spot. Okay, we started at the same spot. Now, this also shows us that the only time that we were ever at the same location is at time is equal to 0 seconds, because we can see here that at no point do my lines intersect for a position time graph, meaning we never have the same position. Now, let's take a look here at scenario 3. So there's a couple of things that we can look at for scenario 3. Okay, first of all, the motion is in 3 different, I guess, parts. Here we have part 1, where we're moving to the right. Here we have part 2, where we are paused. And here we have part 3, where we're moving to the left. You'll notice that there is a little bit of overlap here, okay, for my position line, where part 1 and part 3, we are in the same spot or the same location. And our graph should show us that. Okay? It kind of makes sense, right? If you're moving to the right and then you pause and you move backwards, you're going to cover the same ground. All right, now for our position time graph, let's just do position, meters, we have time in seconds, always have a good title. All right, and if you remember, we did not start at the 0 meter mark, right? We started a little ahead of the 0 meter mark. So I'm gonna represent that by starting off here, okay? Let's do a different color, let's do red. All right, and I believe I was moving, I was moving fast in the beginning, okay? And then, so this is scenario 1, no. And then I was still for 2 seconds. So I'm going to try to draw that as close to no slope as possible. And then I'm moving to the left. All right, so let's break this down. So scenario 1, I'm moving to the right. And we know this because the slope is positive. Here, I'm moving to the left. And I know that because the slope is negative. Okay, so what I mean by that is positive is going upwards, and negative, the line is moving downwards. Here, slope is 0. Okay, so that means your velocity is also 0 meters per second. All right, here my slope is greater. That means I'm moving faster. Then here, slope is less. Okay, which means I'm moving slower. Now, the one final thing that I want to show us is that if you remember, I highlighted this portion here where we cover the same ground. We can see that here, right? So all along this portion, okay, where if this is my position, right? So all along these positions, okay, we were at the same spot. So for example, if I was here at, let's say, 2 seconds, maybe that's not as good because I don't go across. There we go. All right, I was over there, let's say at 12 seconds, right? If I was at here at 4 seconds, I was like here at, I don't know, like 7 seconds. So we are covering the same positions as well, okay, which is different from the previous graph. And that's it. That's how we can connect our graphical model with our vector model. So the last thing that I want to leave you off with is hints on drawing your own motion maps. Okay, first of all, draw dots indicating the position of the object at equal time intervals. For our examples, we use 1 second, but you don't have to use 1 second. You can use 2 seconds, 30 seconds, 1 minute, 1 hour, 1 day. But for our course, we're probably going to stick with 1 second. Attach the arrows to the dots. Arrowhead points to the direction of the motion. So up here, you'll notice that my arrowheads point to the right, meaning I'm moving to the right. Here, my arrowheads point to the left, meaning I'm moving to the left. Don't make the arrows too big. Maybe a half of the size is pretty good. Remember, these are more generalized models to quickly indicate and quickly show others what's happening. And when an object is stopped for several time intervals, there we go. When an object is stopped at several time intervals, draw multiple dots at the same position. And we saw that over here when the object was at rest for 2 seconds. Okay. All right. And that's that. This is one more step towards finishing your physics journey. I'll see you next time. Bye-bye.